What do you think is the meaning of an inscribed angle?
The angle that does not touch the center of the circle.
The center, okay, let's write that part. Okay, say it's an angle. Okay, an angle. What's that, Sal? That doesn't
That doesn't touch the center of the circle.
doesn't touch the center. Okay, anyone else of the circle? Okay, anyone else? Anyone else? So where is the angle? Can I ask you? If you're talking about inscribed angle, where is the angle?
It's in the circle.
It's in, it's out, it's on. Which one?
It's in the circle.
In?
Yes.
So I'm going to say, so this is in the circle. That is an angle, right? It doesn't touch the center. Is this an inscribed angle? What do you think? Is it an inscribed angle? No, these are called internal angles. Okay, they are internal angles, but not central angle. Okay, another type is going to be like this: two chord intersecting together, but not on the center. Okay, these are called internal angles. Okay, an inscribed angle is not in, but it's on the circle. Okay, it's on the circle. Sorry for that. So say here you have that. Okay, you have that central angle, right? Okay, if we're going to make it as an inscribed angle, so let's say this is going to be A, B, central is C, and that's going to be D. Can you tell me what is the name of the inscribed angle?
ADB.
The inscribed angle is what? Angle A, D, and B, or you can say, you can also start from here if you like, B, D, A. Importantly is the angle being named is in the middle. Okay, so what is the theorem for that? So here is the theorem that you're going to take note, gentlemen. Here, for the inscribed angle, okay, for the inscribed angle, let me just put this in. Okay, there is a relationship in here that they are creating. Can you see the relationship that they are looking at here? Okay, and what relationship are we talking here? We're talking about the relationship of the arc. We call it, what kind of arc? It's the intercepted arc. Intercepted arc, and the relationship of the inscribed angle. Okay, inscribed angle. Okay, so there are that is the formula on this. So let's see. Imagine that we're going to put. Let's make this a little bit bigger, maybe. Okay, is that big enough for you to see?
Yes.
Okay. So let's say, what is the measurement? You're going to be given the arc size of, let's say, 80 degrees. Arc. Okay, given is that arc AC is equal to 80. Okay, what is the measurement of angle ABC?
Half of 80 degrees.
It's going to be 1/2 of the arc AC, which is 1/2 of 80 is equal to 40. Got it? That's it. That's your 40. Okay? Okay. Got it? Are you getting the hang of it? It's easy, right? Should easy. It should be easy. Okay. Okay, so let's see. Color, this is another part of your inscribed angle. I would like you to remember this very carefully. Okay, let's add to a new page. Okay, so I would like you to look at this corollaries or additional provision. That's what it means. Okay. So when we say corollary, it's so hard to pronounce on my part, honestly speaking, but I can simplify it to you as we call it additional provision or additional provision, or we call it provision conditions on the inscribed angle. Okay, conditions. Okay, so here we go. What can we say? Number one, what's it saying? Two inscribed angles that intersected the same arc are congruent. So key word in here is the intercepted arc. Okay, so in this case, what is the intercepted arc? Let's put a name, C and D. What is the intercepted arc? Okay, intercepted arc is, what's the name of the intercepted arc? Sorry, arc. The intercepted arc is arc C and D. So this is the arc. So say for example, this is going to be, let's say 78, or let's say 79. Okay. So what is the size of angle CAD? Can you tell me the measurement of angle CAD? CAD and the measurement of angle CBD. C, B, and D. Two angles. What's gonna be the size? Okay, so that's going to be the same rule to your one. This is, so the measurement of angle CAD is equal to the measurement of angle CBD, which is equal to 1/2 of 79, which is what is half of 79? Okay, that's going to give you 39.5 degrees. Okay, so it means to say, gentlemen, that because they have the same arc, these two angles are the same in measurement. Okay, okay, here, second corollary. The angle inscribed in a semicircle, keyword is the word semicircle, in a right angle is always how many? 90 degrees. Okay, so let's see. Let's look at it. So this is A, B, okay? The size of arc AB, okay, AB is equal to 180, right?
Yes.
Okay, so what is the size of angle, what is the measurement of angle A, C, and B?
90.
That's going to be 1/2 of 180, right? Of 180, which is 90 degrees. Is that proven?
Yes.
Okay, you understand now? It's so easy, right? Okay, after this, it's going to be your worksheet. Okay? Okay, so here we go. Corollary. The opposite angles of a quadrilateral inscribed in a circle is supplementary. Keyword? Supplementary. When you say supplementary, how many? How much in total? Is supplementary angle. Opposite angle, example, this one. This angle and this angle are opposite, right? It says that supplementary. It means how many? How much is the total angles? It's 90 is wrong. It's called, that is called complementary. It's 180 degrees. So this one, gentlemen, and this, because they are opposite, this is equal to 180 also. So it means to say that all of this quadrilateral is going to be a total of 360. Got it? So the circle is 360 and the polygon inside is 360 also, because it has 4 sides. Got it? Two opposite angles, just like this one. Look at this square, this rectangle, right? These opposite angles are 90 and 90. Total is what? 180, right? This one and this one is going to be 90 again and 90. So the whole of this is how many degrees all in all? It's 360. Okay, we understand that now? Okay, so that's the lesson all about. Any questions? Okay, we're going to give you an example. Okay, I'll give you an example. That's a very nice question, Brian. Okay, so let's look at some examples in here. This is easy. Before we're going to go to that example, can I please take note again of this thing? There's one more about inscribed angles, and it's really important. Okay. Okay, so what do you see? You can still see what? Okay. What are the things that you should remember in here? There is a what? How do you call BC? How do you call line segment BC? It's a chord. Very good. Oh, you just practiced that today. And what is ray? This is the ray. Let me just put another name in here. Let's say E. Okay, this one is E. So this ray EC is how do you call it? It's a tangent, okay? And point C is what you call the point of tangency. Okay? So here we go. If there is a chord related to the circle, gentlemen, and a tangent, okay? Call it a chord and tangent. Okay? Look at the formula. Did you see the formula?
Yes.
What is the basis of the angle size? Chord tangent, the basis is your major arc. Did you see that? It's the major arc. Okay, so let's look at this one. So say for example, the major arc is around let's say 320. Okay, the major arc. Let's say let's put another one. Another one. BDC, BDC, BDNC. Okay, so can you find here? This major arc is 320. Can you see this one? Okay. Can you find the measurement of angle C? This one. What do you think?
1 times 320.
Sorry, not the major arc, but it's the intercepted arc. Okay, keyword again there is intercepted arc, not the major arc. Look at the intercepted arc. The intercepted arc is BCD here, BDC. So it's called the intercepted arc. Okay, intercepted arc, still the basis. So this one is how many total? What's the total of? Okay, what is the total? Okay, what is the angle? What is the measurement of angle? Angle C. First, we have to find the size of arc BDC, right? BDC arc is equal to what? 360 minus 320. That's going to give you 40. Therefore, the measurement of angle C is going to be 1/2 of the measurement of BDC arc, BDC, which is 1/2 of 40 is equal to 20 degrees. You understand that? Do you understand that? Okay. Okay, so here we go. Okay, this is one again. If you are going to see BDC in here, it is what kind of arc? But it is also called an intercepted, right? Okay, so the keyword is intercepted arc. Okay, the intercepted arc in here is DBC. Okay, and they're asking you to find the angle C in here. So let's say this is 306, okay? 306, okay? Can you find to me the size of BDC, arc BDC? Arc BDC is what? 360 minus 306 is going to give you what? No.
54.
Very good. 54. Therefore, what is now the measurement of your angle C given this thing? Okay, so the measurement here, I'm writing it to you. I'm modeling to you how to write it properly. Okay, the measurement of angle C is equal to 1/2 of B, D, and C arc. Okay, is equal to 1/2 of 54, which is equal to what? 54 is going to 25, 25, 27. Okay, 27. Okay. Okay, you got it now? Okay. Brian, you were asking something earlier about this one. Okay. Are we going to, what was your answer, your question in here?
Use the same steps to find
No, you're not going to use the same step. Okay, so example, let's give you an example for you to understand very well. Okay. So how do you find the angles? Okay, how do you find the angles? Can I just zoom this in a bit? Okay, is that much better? Okay, so imagine I'm going to give you only two parts of the side. Okay, so let's say given that the measurement of your angle B is equal to, let's say, 80. Okay, and the measurement of angle A is equal to, let's say, 120. Okay, find the measurement here. Find the measurement of angle D and the measurement of angle C. So how do we do this? What did we say about this one anyway? Okay, opposite angles are what? Supplementary, right? So how do we do that? If you cannot do it mentally, then write it down. You write the measurements. It says that angle B is 80, right? And angle A is 120. Get it? So now, opposite angles. Opposite angle of A is C. So what is the measurement of this? Everything is 180, right? This angle A here, the measurement of angle A plus the measurement of angle C is equal to 180. And the same thing with the measurement of angle D plus the measurement of angle B is going to be 180. Now you're given these two dimensions already, so it's going to be very easy for you, right? So this is going to be what? It's going to be 60. And this is 80? Okay, you got it now? Get it now? I have another question though. If angle B is 80, what is the size of arc AC? Okay, okay, let me just write it down. Here's the question. If the measurement of angle B is equal to 80, what is the measurement of arc AC? Is equal to what? It's 40. Why 40? Okay, I'll give you the answer. The answer is going to be the measurement of 80 multiplied by 2 is equal to 160. Why did we multiply by 2? Okay, why did we multiply by 2? Because if you're going to be looking at your first lesson, you still remember your first lesson in here, in the inscribed angle here? Okay, this is from the arc going to the to the inscribed angle, right? Okay, look at the direction very carefully. Okay, so look at this one. They are giving you the size of the arc going to the inscribed angle. So that's going to be 1/2 of the intercepted arc, right? Intercepted arc. However, the direction this time is coming from the inscribed angle going to the arc. Okay? So what are you going to do? What's the reciprocal of 1/2? 2. So times the angle, we call it the inscribed angle. We call it, how do you say? We're going to say 2 times the measurement of your inscribed angle. Got it? Okay, so let's give you a simple practice, simple understanding. Okay, so let's imagine this one. This one is going to be, let's say, give me a number, Sal. 30. Okay, this is going to be 30. If this is going to say, if the measurement of angle angle B is equal to 30, okay, what is the measurement of arc AC? It's going to be what?
160.
Why 120? Times 2. 30 times 2 is? Okay, so you're going to be multiplying it by 2 times the measurement of angle B. Okay, that's going to be 2 times 30 is going to be 60 degrees. You got it? It's back to back. You got it? So in here, if you're going to be given the arc size, it's going to be 1/2 going backward, correct?
Yes.
But if from the back going forward, you multiply it by 2, and 1/2 and 2 are reciprocal. Did you see that? Okay, you understand now? I've been talking too long. You understand now? Very easy, right? That's what I would like you to do. You're ready for AP Calculus, guys. Okay, I guess that's all for today. Okay, so let's recap before you guys are going to. So you're going to look at inscribed angle. Okay, so now do you have now a clear understanding of what is an inscribed angle? Where is the inscribed angle? It's on the circle. Okay. Okay. Theorem number 1. What's the theorem number 1? The relationship between the intercepted arc and the inscribed angle is 1/2 of the intercepted arc. Okay. Keyword intercepted arc. Okay. Okay. Here, what did we study in this part? So here there are the corollary for this lesson. Okay, still inscribed angles, and we said that two inscribed angles, if they have the same or the same intercepted arc, their measurements are the same. Okay, inscribed angle in a semicircle is a right angle. Okay. Okay, third, the opposite of a quadrilateral in inscribed circle is a supplementary. Brian, did you understand this part?
Yes.
Okay, and last but not the least is this one. Okay, so are you ready for your worksheets? Okay then, that's very nice.